Okay guys, the difference quotient is going to be a part of the second half of section 1.1, but it's a large enough standalone thing that I think I need to have its own lesson on it. This you guys saw was the same screen, same set of values that you guys saw for the first part of section 1.1, and I just need to go through and make sure that you guys are okay with what I was saying. The advice I'm giving you is, when you go to evaluate a function, write the function without the variable, put a parenthesis in place of it, and then fill in the value that's inside the function that's being described. If you do this, it will be foolproof. You will never make a mistake. Don't heed my advice and, well, we'll see where that gets you. Okay? So that's 15 minus 2, so your answer is 13. This one, same thing, write it without the variable, put parentheses in its place, and then fill it in. So 3c minus 2. For this one, 3 plus 2. Oops, minus 2 in a row. I guess I was getting ahead of myself. Alright, minus 2. And then you're going to fill in there the x plus 2. So 3x plus 6 minus 2, 3x plus 4. And this one, I don't think I need to walk through it. I did it just a lesson or two ago. So wanted to remind you guys, that was the advice I gave you, was you write the function first without the variable, parenthesis in place of the variable, and then fill what's inside it inside. This is the difference quotient. This piece of it, you guys will learn fourth quarter. So there's a bunch of math that has to happen between now and then before I can teach you how to do this part. But this, at least the kids I had back in Algebra 2 did it. Whether they remember it, that's a different issue. But this is the difference quotient, and what it finds for you is slope. More importantly, the only thing you guys have been able to do with slope so far is find slope on the equation of a line. This would be the slope, or this would be the slope, depending on how you wrote the equation of the line. And the basic definition, rise over run, has always been for a line. How much are you going up? How much are you going over? Well, you can describe and you can calculate the slope on a curve. You can find out right there what's the slope, or right here what's the slope, or right there what's the slope. How steep is the curve at that location? This will find it for you. And as we go through this process, I would like you guys to be more and more comfortable without just going through the motions and doing it, without just having to train you how to do this, but to actually understand why this is finding slope. Why is the top rise, and why is the bottom run? Okay? But we'll get there. So at first, you're going to be kind of deer in the headlights, and you're not going to be sure what's going on. And that's why I've chosen for you an equation. You already know the slope. So you know that this is a line and the slope is 3. I just want to convince you that it's actually working. What I need to do is train you guys once again, do this thing in pieces. This will be the first step. This will be the second. And then you put the whole thing together and divide it by h, and that'll be the third step. So you're going to do it in 3 pieces. First thing, write the function without the variable, parenthesis in place of the variable. That's what I've been training you to do. Then fill in x plus h. Simplify it. That is just this much information. Then you have to subtract the original f of x from it. You're going to subtract f of x, and this is what it's worth, minus, and you're subtracting the whole thing, so I'm going to put it in parentheses. So I got 3x plus 3h minus 2 minus 3x plus 2. Now that's the second step. That's the whole top. Now I'll simplify it. And I got 3h. That's the top. That's the first and second step completed. Third step, divided by h. So without even knowing how to do a limit, you were able to find the slope. Now that's because the thing's a line. You don't need to do the limit to find the slope of a line. I just wanted to convince you that this thing is actually finding slope by doing it on something you already know what the slope is. So let's do it on one where you don't know what the slope is. Again, you're not going to be worried about the limit part. You're just going to be doing the difference quotient, this thing. Okay? Here's your function. Write the function without the variable, parenthesis in place of the variable, and then you're going to fill in x plus h as the first step. So that's your first step. Evaluate this function at f of x plus h. So you've got it written out. I'm going to put in the x plus h. Now, those of y'all that are in this really bad habit, let me show you again. You cannot distribute this. That's 5 squared is 25. If you try to distribute this sucker, you get 3 squared plus 2 squared. That's 9 plus 4 is 13, not 25. Okay? You can't distribute this. You can't distribute that in. You have to FOIL this out. I was going to do it a different way, so let's just stick with FOILing, okay? First, x squared plus xh plus xh. Whoops. I'm trying to do this quickly and I'm making mistakes. Plus xh plus h squared. Now once again, guys, when you got a perfect square, let's find a shortcut for it. Square the first thing. You're always going to get 2 of these when you multiply these together. So double it to xh. Then you're going to square the back. Plus h squared. That is this expanded. So 3 x squared plus 2xh plus h squared minus 2 times that stuff plus 6. Distribute the 3 in. 3x squared. Whoops. Sorry for the mistake. 6xh plus 3h squared. And then this stuff is going along for the right because you did it in the last step. Okay? That is just the first step. Now you have to go through and subtract the original function from it. That's the second step. This is the original function, and you're going to subtract it from this. So you're going to subtract minus 3x squared minus 2x plus 6. So in other words, you're going to minus 3x squared plus 2x minus 6 from this equation in red. Minus 6 plus 6, 2x minus 2x minus 3x squared plus 3x squared. So f of x plus h minus f of x is what's left. 6xh plus 3h squared minus 2h. And at this point, everything should have an h. Each term, that and that and that, each need to have an h. If you don't, you've done something wrong. And for the last step, you're going to divide it by h. And a little bit about dividing. 3 plus 6 over 3. You know that's 9 over 3, which is 3. Okay? When you reduce, when you're adding and subtracting, it needs to reduce with everything. Otherwise, this is 7, and you know it's supposed to be 3. 1 plus 2 is 3. So in other words, this h is going to reduce in each piece. That's why it's important to have an h in all 3 pieces, because if you don't, it doesn't work. Plus 3h minus 2. This is as far as you guys can take it until you learn about taking a limit. That's the answer. So let me walk you through what your homework's going to look like. I've set it up where that's the function, and then this is each of the 3 steps that I just walked you through. The third step is dividing by h. So let's do it for this one. Write your function without the variable, parenthesis in its place. Then in that parenthesis, fill in x plus h. You know the expansion of x plus h now. That is f of x plus h. Here is f of x plus h. Don't reinvent the wheel. Don't do it again. Just copy that answer over. from this column. You're just going to write it up here. Okay? 2xh plus h squared plus 6 minus the original function. So then you're going to subtract the original function from it. Minus x squared minus 6. Simplify it. And you're left with 2xh plus h squared. That is the whole numerator here. So just copy that answer over because you did the work for the numerator. 2xh plus h squared. Now divide it all by h, and an h cancel out in both places. So your answer is 2x plus h. Okay, that's your answer. And you're to fill out this whole sheet for your homework.